Hi there. In this lecture, we are going to discuss the uniform distribution. For starters, we use the letter U to define a uniform distribution, followed by the range of the values in the dataset. Therefore, we read the following statement as, variable x follows a discrete uniform distribution ranging from 3 to 7. Events which follow the uniform distribution are ones where all outcomes have equal probability. One such event is rolling a single standard six-sided die. When we roll a standard six-sided die, we have equal chance of getting any value from 1 to 6. The graph of the probability distribution would have 6 equally tall bars, all reaching up to 1/6. Many events in gambling provide such odds, where each individual outcome is equally likely. Not only that, but many everyday situations follow the uniform distribution. If your friend offers you 3 identical chocolate bars, the probabilities assigned to you choosing one of them also follow the uniform distribution. One big drawback of uniform distributions is that the expected value provides us no relevant information. Because all outcomes have the same probability, the expected value, which is 3.5, brings no predictive power. We can still apply the formulas from earlier and get a mean of 3.5. And a variance of 105 over 36. These values, however, are completely uninterpretable, and there is no real intuition behind what they mean. The main takeaway is that when an event is following the uniform distribution, each outcome is equally likely. Therefore, both the mean and the variance are uninterpretable and possess no predictive power whatsoever. Okay. Sadly, the uniform is not the only discrete distribution for which we cannot construct useful prediction intervals. In the next video, we will introduce the Bernoulli distribution. Thanks for watching.